Okay, in this video, we're going to go over independent and dependent probabilities. So let's first start with independent probabilities. This means the first event does not affect future events. If I roll this die and I flip this coin, these two events are independent of each other, meaning if I roll this die, I got a 5. Does that in any way affect whether I get heads or tails? No. I flip the coin really poorly, and I get heads. Whatever I got on the coin was not at all affected by getting a 5 on this die. They're totally separate of each other. They didn't affect each other. They have no relation. So let's go over a couple examples of independent events before we get to dependent. A spinner and a number cube are used in a game. So we have a spinner and a number cube. What is the probability of a player spinning green and then rolling a 2 or a 4? So first let's talk about the spinner. I'm going to roll green, and my chance of doing that is 1 out of the 5 sections. Now getting green has no effect on what I'm going to get when I roll this die, because I still could get a 1, 2, 3, 4, 5, or 6. So what's my probability of getting a 2 or a 4? Circle those. Well, that is a 2 out of 6 probability. So what's the probability of both of these things happening? In order to find that out, you have to multiply them. So I'm going to do 2 6 times a fifth, and I get 1/15. Next one. What is the probability of a player not spinning purple and then rolling an odd number? Well, if you're not going to spin purple, then you got some options. You can spin red, green, yellow, or blue. There are 4 things you could spin out of 5. So there's a 4/5 probability of not spinning purple. This has no effect on what you get when you roll a die. You could still get a 1, 2, 3, 4, 5, or 6. So what's the probability of getting an odd number? 3 out of 6. What's the probability of both of these things happening? You need to multiply them. 3 6 times 4/5 is 2/5. All right. Now, let's talk about dependent probabilities. Ooh, this should say first. No, this video is going so well. Well, I'm not going to stop. So for dependent probabilities, the first event does affect future events. And we're going to go over that in these problems below. Mr. Smith's class has 6 students with blue eyes. 1, 2, 3, 4, 5, 6. 6 students with brown eyes. 1, 2, 3, 4, 5, 6. 1 with hazel eyes, which I'm going to represent with this color, and 1 with green eyes. 2 students are selected at random without replacement. You're going to find out that this is what makes it dependent. Find each probability. So first, we are going to select a student with hazel eyes. What's the probability of that happening? Well, there's 1 student with hazel eyes out of, 6, 12, 13, 14. 14 total students. So the probability of picking this 1 student with hazel eyes is 1 out of 14. But that student is not replaced. So I'm going to cross her off. She's out of there. These are the people that are left. So how many people are left? 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now what is the probability of the second student I pick to being a student with blue eyes? Well, there's 1, 2, 3, 4, 5, 6 students with blue eyes out of 13. Probability of both of these things happening, I'm going to have to multiply, and I get 3 out of 91. All right. What is the probability of choosing 2 students with brown eyes? So I'm resetting the problem. There's 14 students. I'm going to pick the first student. What's the probability they have brown eyes? 6 out of 14. Then I don't replace that student, which means that student is no longer in the room, which means that there's now 13 people to select from. See how the first choice affects the second choice? That's why it's a dependent probability. So what's the probability I select a student with brown eyes now? Well, there's 1, 2, 3, 4, 5 students with brown eyes left out of the 13 students that are left. And my answer, when I multiply those together, is 15 over 91. I hope that was helpful. Please see me if you have any questions.